Good evening everyone. Let us begin with today's session on misconceptions in physics. Okay, we are continuing with our old chapter which is on rotation, and towards it, just a moment, it's not opening. Yes. Okay, so the topics that we will be discussing on are topics like torque, moment of inertia, angular entity, quantities, and so on. Okay, so this is a topic which is applicable for CBSE, ICSE, IGCSE, IBDP, and EdExcel. In fact, in IBDP, you study this course, this particular chapter, in the chapter on engineering physics, which is an elective option. And my name is Ratan Kar, and I teach physics in one of the international college schools in Bangalore. And my passion is teaching. So this is a consequence of students' request and all of my friends, okay, who suggested why don't we start something like this, and this is what we have started. Okay, so now if you want to know more about myself and or my earlier videos, you can just go to my website. My website is at, just a moment, I think it's been connected. Oh, just a minute. My website is available at my website is available at the following URL. You can visit this website, or maybe you can you can subscribe to my channel, and you can avail all the videos free. Okay, now let us start with this one. This is about how do you calculate the force in rotation. Generally students have an thinking that whenever we talk about force calculations, the first thing that we need to know here is that we have F is equal to M into A. Okay, so if we know this, then definitely you can easily find out. And towards it, you need to get the value of mass. So mass is already there here. And you need to get the acceleration. Which acceleration is this? Linear acceleration. Okay, let us read the problem. A wheel of mass 10 kg, mass is given, and radius 20 centimeter, R is given to you, is rotating at an angular speed of 100 revolutions per minute. Okay, so it is given. When the motor is turned off, that means it is no more applied. When the motor is turned off, so at that time it was revolving so much. So that means it is omega I over here. Initial angular velocity is given to you. And when the motor is turned off, when there is no other force acting on it, what will happen? The wheel starts slowly coming down its speed or reducing its speed. Neglecting the friction of the axle, calculate the force that must be applied tangential to the wheel to bring it to rest in 10 revolutions. So what he says is, okay, I don't want to naturally bring it down, but instead I just want to touch it, so that I need to apply a tangential force. So that I want to bring it to rest into 10 revolutions. So towards it, the student had thought the misconception here. Let us look at the solution. The student has thought, using these data, if I am able to get the linear acceleration A, I can easily calculate what is the force applied, F equal to M into E. Now towards it, if I want to get A, so is A given to you? No. The first what he does is, he does something like this. Finds out the angular displacement when theta equal to 10 revolutions. Because angular displacement is being found in terms of radians. Okay, so if it completes one full revolution, it is 2 pi radians, that is 360 degrees. And if it completes 10 revolutions like this, which means 10 multiplied by 2 pi, which is equal to 20 pi radians. Okay, so this step is correct, no issues. Then omega I is equal to 100 revolutions per minute. Okay, which he converts it into 100 into 2 pi by 60. How do I get this? 1 revolution is 2 pi radians, which I have substituted here. Then 1 minute is 60 seconds. So therefore, when I do this, so this one's 1 0 and 1 0 goes away here. Then you get 2 3s are and 2 5s are, and then 5 2s are. So thus I get the answer as 10 pi by 3 radians per second. This step is also correct. Okay, so initial angular velocity has got it correctly, theta has got it correctly. Then omega final equal to 0, hence 20 pi is equal to so much. What has he done here? He has used this equation. He says that whenever the angular acceleration is constant, you can always write theta is equal to omega I plus omega F divided by 2 into T. I hope you remember this is a special equation of motion. Which one is this? If you remember, we have written in equations of motion in linear mechanics as displacement S is equal to u plus v divided by 2 multiplied by t. Okay, what is this u plus v by 2? Which is nothing but v average into t, right? S by t is equal to v average. We can use this equation only when the acceleration is seen to be a constant. Okay, so here also you see we have said very clearly that there is an angular speed is so much and you need to apply a constant force, which means he assumes that the angular acceleration should also be a constant, because you are going to apply a constant force, right? Constant force means constant acceleration. Constant acceleration means it is constant linear acceleration, and then it also means angular acceleration. Okay, so as a result of this, he uses this particular equation, and then he says 20 pi. Okay, what is 20 pi? 20 pi is nothing but the displacement. Which displacement? Angular displacement. Angular displacement is equal to 10 pi by 3 plus 0. What is 10 pi by 3? 10 pi by 3 is nothing but the initial angular velocity. What is this final angular velocity? Okay, because it comes to rest, multiplied by t, similar to this t, divided by 2. Okay, solving this equation, you get the answers t equal to 12 seconds. That means the time taken by the flywheel or just wheel to come to rest when you apply a constant force is seen to be 12 seconds. Okay, now based on this value of time, now what has he done? Where is my cursor? Yeah, it's here. Okay, so what has he done? He has found out the angular acceleration. How does he find? Angular acceleration is nothing but omega f minus omega I divided by t. How do you get this equation? A is equal to v minus u by t, right? If you want, I will write it down here. I'll write down A is equal to v minus u divided by t. You remember which equation is this? This is nothing but the equation of the acceleration, right? Which you have used it while you found out the acceleration. So here it is in linear motion, right? In case of the kinematics. Now if I want to do angular acceleration, I am going to replace this A by alpha, then v. What is this angular acceleration? This is alpha. Then v. What is v? Linear velocity. Now I will put this as angular velocity and u, angular initial velocity. Now this divided by the time taken. So I will substitute all this. So omega f minus omega I by t. Omega f, what is omega f? 0. Why 0? Because the particle comes to rest. The wheel does not turn around, right? 0 minus, what is this 10 pi by 3? How do I get this? You see here, I have got it from here, right? 10 pi by 3 divided by time. Just now I found out 12. Okay, and thus simplifying this, I get the answer as minus 5 pi by 18 radians per second square. What is this angular acceleration? You see, the equation is also consistent. See, this radians is what? Angular displacement divided by second square. In linear acceleration, what did we have? Meter per second square. What is meter? Linear displacement. See, you have to correlate between the kinematic term and the angular term. That is the linear and the angular. Okay, so you just need to see to it that how closely they are going hand in hand. Okay, now we have got this. Then linear acceleration. Now what is the expression for linear acceleration? A equal to, you have read this also, A is equal to r into alpha. So based on this, he finds what is r? R is 20 centimeter. See, 20 centimeter. Substituted here. Alpha. Alpha, what is alpha? We already find here. Substitute this value. 5 into 0.2 becomes 1. So it becomes minus pi by 18. What is the equation? Sorry, what is the unit? Unit is meter per second square. Wow. We have got the angle linear acceleration also. Next, finally, he puts force equal to m into a, which is 10 kg multiplied by this, which is equal to minus 5 pi by 9. Why negative? Negative because it's a negative force. You are applying a force to stop the object, right? So it has to be negative. It's a retarding force. Everything is fine. See, so nicely, so wonderfully he has calculated everything. Okay, you should definitely say, sir, you should give him 10 marks. Right? So much complex calculations he has done. But unfortunately, he won't get that. Because he had made a mistake. The concept is incorrect. Okay, let us see what goes wrong here. What is a misconception he has used? Now, until here it's correct. Where is it? Until finding out the initial angular velocity, final angular velocity, finding the time taken. Until here, an angular acceleration. Until here, everything is correct. Until here, everything is correct. You won't get 0 for this. Okay. But when it comes to linear acceleration, when you are using A equal to r alpha, now what is this A? This is your center of mass acceleration. Right? This is a center of mass acceleration. This is not, say for example, if a wheel is rotating like this, and you ask me what is this acceleration A, this is your center of mass acceleration, which you should write this as r into alpha. Okay, so you should not use this one here. You should not use this one here. So therefore, now these two quantities goes wrong. This two goes wrong. Because you calculated linear acceleration in this manner and you also calculated force. The force that you are writing down here is not this one, but instead this force is nothing but what is the mass that you need to apply at the axle. Did I ask axle? No, I had asked you calculate the force that must be applied tangential to the wheel, which means what? I need to find out what is the acceleration at this point. I need to find out what is the force that I should brush it across. Okay, so that is where this goes on. Now I hope you are clear about the incorrect usage of the concept. Okay, now let us move on to the next one. Now what is the correct solution? The correct solution looks like this. See, I have not changed anything here. I just written all this, and what I will do is I will just tick mark which ones are correct. I'll say this is correct, this is correct, this is correct, this is correct. This is just a moment, wait. I need to change something here, so only then this would be proper. Okay, now I hope it's fine. Yeah, now it's fine. Okay, so therefore this time equal to 12 seconds is correct, this is correct, and 25 radians is correct, and now this is also correct. Until here it's correct, except that these two are incorrect. Okay, now we need to change only these two. Now how do I get the linear acceleration? Okay, if you want to get a center of mass acceleration, you can follow this method. If you want to get a linear acceleration tangentially, you should not use this. Remember this. Now towards it. Now what is happening here? You have the wheel. The wheel is rotating with an angular acceleration alpha. It has a radius r. Okay. Then what is that you are asking? You are going to apply a force here tangentially. You are going to apply a force F here. So which means now there is a torque. There is a torque here. The torque here is F into R. Okay. The torque that you need to apply to stop it. It's an angular force, right? F into R should be equal to I into alpha. Right? This is the equation that you need to use. So force into radius should now be equal to what is I? I is nothing but mr square by 2. Mr square by 2, which is moment of inertia, multiplied by alpha. What is alpha? A divided by R. Okay, you can use this here. Now as a result of this, now F into R is equal to so much R. You can now write the tangential force that you need to apply here is nothing but M. No, wait. This R and this R I will cancel. This R and this also I will cancel. So this should now be equal to MA divided by 2. Now what is M? 10 multiplied by A. What is A? A, what is A here? A is, we have not got the value of A. So linear acceleration, yeah, so sorry, this part is also right, which should be pi by 18 divided by 2, which should now be equal to 5, which should be 5 pi by 18. Now when you calculate this, what is the answer you get? Let us find out. 5 pi by 18. Okay, let me just keep it like this. Minus 5 pi by Newton. See, until linear acceleration is correct. Okay, only this, the force that you compute here is incorrect. But if you ask me, can I get full mark, or maybe out of 10 marks, how much marks will I get? You can definitely get around 8 marks. 8 marks you can get, because everything else is correct, but this part is wrong over here. Okay, 2 marks you get it wrong. One mark you will get it wrong for the concept, and 1 mark you will get it for the value of it. Okay, so thus you get half the value. That's the only difference over here. Here you get minus 5 pi by 9. Here you get minus 5 pi by 18. Right? But still you lose 2 marks here. So it is all because of the misconception. Okay. So I hope you understood this particular problem, like how to get this. And if you have liked this video, do share and subscribe to my channel for more updates like this. Thank you, friends.